hopefully my dog is not gonna start like,
what dog
going
do you
crazy. I have a rescue dog, like from Crete. It's a Cretan Hound type, so I don't know if that helped, but he is hunting guardian dog. So
I see. Love dogs.
there you go. Imagine.
Oh, that's sweet.
That's alright. But yeah, I guess we can. If he does that not too long, I guess we can leave it in. We don't have to.
Sure, of course.
Yeah.
That's what differentiates us from AI-generated content.
That's true. Though soon you'll be able to add dogs. All right, let's get going then.
So, welcome to Root Cause. I'm Nuna. This is where we get to the root cause of things. Architectural decisions that aged badly, leadership transitions nobody prepares you for, or the hype cycles that keep repeating themselves. If you have ever thought, am I crazy for questioning this? You're in the right place. Today's conversation is about the gap between how we think system works and how they actually work. And resilience engineering has a name for this. Work as imagined on one side and work as done on the other. The gap has always been there, and yet most organizations spend their energy trying to close it, when the more interesting question is what we could actually learn from it. How we keep our cognitive capabilities sharp when the systems we're responsible for are getting further and further from anyone's full understanding. And who better to talk about this than the resilience expert himself? My guest today is Adrian Hornsby. Adrian spent over 2 decades in software engineering and operations. He started as researcher at Nokia, working on distributed systems, and then he has built messaging systems that handle millions of users. Afterwards, he spent 9 years at AWS as Principal Engineer on the fault injection service team, helping some of the largest systems in the world survive the things that nobody plans for. About a year ago, he left AWS and founded Resilium Labs. The premise of the company is simple and quite uncomfortable. Organizations have been investing heavily in resilience for a decade. Chaos engineering, game days, operational readiness reviews, incident retros, and the same incidents still keep happening. Something organizational is broken. And honestly, as I've come to learn later in my career, you can't engineer your way out of a human problem. His new book is called Why We Still Suck at Resilience. The book argues that resilience practices keep failing not because they're poorly implemented, but because the organization itself systematically turns learning mechanism into compliance theater. From my short interactions with Adrian, I can tell you he's approachable, kind, and someone who thinks in public. He writes a lot, he disagrees carefully, and today he has found time for me. Hey folks, before we continue, I wanted to mention that Adrian has generously decided to run a discount with a promo code RootCauseByNune. For the first 30 copies, you can buy his book for as low as $14.99. That's over 70% discount over the usually suggested price. Link is in the description. And if you want to support this podcast, hit subscribe and share it with your friends and colleagues. And now, back to the conversation. Adrian, welcome to Root Cause, and I'm happy you could make this work.
Thank you for having me, and thanks for the warm introduction. I'm not sure if I'm the expert, I think, but I'm a student of resilience engineering discipline, which is very broad and long.
Well, at least I got to know more about resilience engineering from your posts. And then when you start digging into it, it's an endless information about it, coming to how we think, our cognition, how organizations work. It's an interesting topic.
It's a challenging topic as well.
Yeah, for sure. And I want to start with something you told me when you learned the name of my show, and we joked around that a lot. You told me it should have been Root Causes, plural. Can you unpack that a bit for me and the audience, why root cause is?
Yeah, the I guess the short answer first is simply that I think it's comfortable to think there is one reason something fails, but in practice, it's never like that. It's the accumulation of small things happening at the same time that creates the condition by which systems fail. The long answer really is it can be very long, right? It's about the nature of complex system, right? And how system fail in what's called emergence, right? Is the interactions of components that often fail. It's rarely the component themselves, it's their interaction. So you can have two components working very well by each measure of the component themselves, but the interaction creates the problem. And if you start to think about systems like that, then you can unpack almost an unlimited reason of why system fails. And then root cause is really from the old industrial time where you had, like, for example, an assembly line, and something would fail, and then you would say, okay, let's go and fix that. That would be the root cause. And it got carried away to software systems through Safety One. If you're interested in resilience engineering, you hear the term Safety One and Safety Two, and kind of and for some reason, people have liked to try to have one root cause, and I kept using it, and still today you use it. So yeah. That's the long story. Sorry, I got carried away again.
No, it's perfect. It's perfect. I personally picked root cause because I like to dig into things. Like I like to find the reason things happen and not just stay on the high level. And you keep asking why, and then hopefully you get to one or many root causes. Mm-hmm. But now I'm a bit getting stuck with the name in a way that whenever I choose a topic for the episode, I have to formulate the name in a negative way, because you usually don't go looking for a root cause of a good thing, which is probably also not correct. We should definitely also look into things that went well and try to unpack why things went good this time and not bad.
And you're touching on something so important to resilience engineering. You know, the default when there's an incident is to look at what went wrong. But if you think about systems, they go well most of the time, right? Like most of the time it goes well. And simply at the moment, because emergence happen, the context by which the system plays starts to create failure. And this is what we want to understand. We want to understand what worked well in most of the scenario, and then the context when things went wrong, so that then we can, really understand what happened. So yeah, like saying root cause actually is a problem in incident analysis today, because it forces engineer, or kind of it biases engineer, anchors them to look at what went wrong, when we should also ask, hey, what went well, like, and and see how we can actually do more of that.
Even in our day-to-day life, I think every person, or that we are as humans wired to think about the negative things that happen and why this went this way or not the other way. But when you think about it, how amazing it is that a day goes by smoothly, how many millions of possibilities there are for things to go wrong when we leave the house, and yet it didn't happen. So we need to, all the cliche appreciation of the good stuff. Yeah, same with organizations. There's another term that I think we'll use a lot today, and for people who maybe are not familiar with the terminology, there is work as imagined and work as done. can you explain this gap between them, and maybe if you have an example, a disastrous example of happening as a gap, also that.
Yeah. So the work as imagined is kind of the version of work that typically lives in documents, whether they are diagrams, runbook, organization charts, and the slides. And they're really clean. It's what we write when we are caffeinated during the day. We are all happy, smiling. And it's clean. It's very logical most of the time. It's defensible to auditors and to leadership because that's what we design, right? But the work as done is what actually happens, right? It's what you do when at 3 a.m. you're on call and you skip a few steps in your runbook because you've learned that those steps are not the right one. They haven't been updated since 6 months, the last version 6 months ago that was deployed. Or it's the engineer that learns that, for example, a particular alert is more important than another, right? So you start to learn the how the system behaves in production, and all of that is often not in the design docs. It's not in documentation. It's certainly not in the architecture, and what is really important to understand is it's not the deviation. Like work as done, it's not the deviation of as imaging. Is just a structural gap, right, that happens naturally in every system. Well, first you need to have an idea of what you're going to build, right? And then between the idea and what gets implemented, there's already a difference. And then you make shortcuts, you forget to implement something, or you implement something else. So naturally there's kind of a natural difference between what you've imagined in your head and what gets done. And so as an engineer, you need to understand that, because we often think about our system from the imagined world, but we really look at it from the done. And the only situation where you look at the done is when there's an incident like that. That's kind of the reality knocking at the door and say, it's not what you imagine, right? So that there's an incident here. And so that's why, like, when you have an incident, you typically don't want necessarily to understand what went wrong. Is you want to understand what did the incident surface between what you imagine and what is done, and kind of what surprised you. Like, you can summarize this as what surprised you, and what changed in your mental model. That's the only thing to do. The only thing you can do in that situation is learn from it, right? And that's why I often say the only answer to understanding that gap is learning. That's kind of the thesis of the book.
There are so many layers to what you're saying, and so many thoughts on that. First of all, when I started in the IT, and when you are not leading teams yet, right? You're solo, you're implementing, and you kind of do all of the steps yourself while you're learning. You develop something, you usually deploy that something, and you test it. So you naturally know every step of the thing that's done. And
you
then
think you know, right? But you never do everything. You never test everything.
At least you try. At least you try things out. And what always surprised me is this role of a software architect. And I have seen organizations where the software architect is not coming from software development. He's only, or she's only architect. And that is a bit surprising to me, because that means this person lives in the quite perfect world, as you said, of not being tired and having time to think about the system, about the good or bad outcomes, and then architect that system. Maybe that's a good thing because they need this time to think about it. But on the other hand, how can you be a good architect without ever touching the code? Do you think you can be one?
Wow, there's a lot to unpack here. So let me go back to the first argument about architect, having a version of the imagined world and kind of thinking about first, it's not just architect. Actually, often you also have senior engineers that naturally, as you grow in seniority, your areas of work expand across the organization. So you spend less and less time on the day-to-day operation, right, of the service, and because of that, you start to your version of the imagined reality, your version of the software you have in your mind is slowly detaching from the work has done, because naturally your work is spreading. Like, I was principal engineer at AWS. I had a real big gap between my imagined version of the software and what was done on the ground, because I was dealing with a lot of different things, right? So it's not the role thing. It's really like a structural feature of organizational growth, right? And kind of promotion and all this kind of stuff. So and it has a cost, right? Now it's often why I say that the more senior you get, and when you start to realize you are detached from reality, you need to switch from decision maker to decision enabler, right? And this is where you kind of change your role from making the decision about how things should be done in the real world, in the done world of work, versus helping people at the edge making better decisions through your knowledge, your experience, and often this is maybe where you see that not happening in organization, because when you move away from the done, you kind of lose grip on it, and then you want to keep making decisions, keep being relevant. So it's a resistance to this being detached from reality. So yeah, the long story short is, yes, those kind of roles are detached from reality, and they make decisions that impact other people at 3 a.m., and that's a big problem. But it's not just architect. It's really any role that is being detached from reality and that keep making decisions, right? So yeah, that's kind of often like the team will absorb the difference between what the decision making team does, kind of, and then what they actually do. Does it make sense what I'm saying?
Yeah, it does. And often, yes, it creates the tension. But I think we also need to understand that that's what abstraction is for. Like, for any human, in order to be able to think and make decisions about any system, we have to abstract it and create models of it in order to be able to judge about it. So there's no way around it. And also one thing that charity majors, I think, introduced, which is the manager pendulum, is when you need to come back to the development every 2-3 years, so you don't become too detached. For my background, when I had a previous startup and now I'm building a startup, it's naturally happening that first you develop it yourself, and then you kind of have to find a team around what you have built. So naturally you go higher in the abstraction, and then if you build another component or if you build another department, then again you are back to the trenches and hands-on work, and then you get out of it. So for me, it's hard to accept that this gap exists, and you need to embrace the gap instead of trying to fix it, because the gap is not going anywhere. There must be people who deal with the high level, and then there must be people who can actually do the hands-on work. And it's different mindset, it's different style of
it's
working.
Different role.
Yeah, it's a different role.
I think I'm not sure if kind of going back, as a manager, going back to development is the right thing. I see now a lot of CTOs with vibe coding and talk about that. I'm not sure if that's the right thing to do. I think the better, at least an easier thing to do is to recognize that you're not adequate anymore to make the decision, right? So it's a kind of delegate to people at the edge and giving them and kind of freeing them from the roadblocks they have to make those decisions. And I think that is much better. Like, I love the idea of you build it, you run it, you operate it, you fix it, because that's exactly that. Is like people that actually run the system make those decisions. And I think it's not the bad thing if you're detached, right? It's just recognizing that is difficult, and people clinch on making decisions because it feels powerful, it feels like you're relevant. But I think it's just a mindset. It's like you can be as relevant as a coach, as helping other, and it's even more rewarding. It's just you realizing that your job has changed, like you're enabling others, right? And I think it's just that. But that flip is very, very hard. It's actually, having been involved in a lot of promotion at Amazon, it's actually what was the hardest part from senior engineer to principal, is like people flipping from being the expert in the room to being the enabler. Does it make sense?
Well, that's something I struggle a lot with. I mean, to be honest, it's very hard for me to delegate things. And it's a completely different skill set. I think it has been said a lot, yes. But when you work technically on technical things and you get good at that, and then suddenly this other role of enabling other people has a lot less to do with technical abilities rather than empathy, knowing when to direct and when not. My friend has an article how that's similar to raising a child more than software engineering, because you need to be strict when you need to be, but also you need to be able to say it in a way that doesn't hurt the other person. So it's hard for me to grasp until now, but also on the technical sides, sometimes I feel like you shouldn't vibe code into production code. But if you are about to introduce a new technology into your team, shouldn't you at least know more about that technology? Or do you need to always just find a person who knows it and enable that person?
Well, it's a good question. I guess I'll put that in two buckets, right? I think the first bucket is maybe, and I'll ask you, right? Maybe the fact that you can't let go of being, involved on the day-to-day in the technical details is maybe because you're building and you're not sure where you're going, right? And I think that's probably what I see most, is like people build or have an idea of what they want to build, but it's not very well defined. So the kind of the feeling you have is that by not being there making the decision, is like somebody is going to change potentially the idea of what you think you might be building. You see like all those level of
I'm not that worried about changing the idea. I hope I'm not that clingy to the ideas that I don't want them changed. But it's more of that I feel highly responsible that I haven't thought everything through yet. So how can I ask another person to implement it when I don't think I have all the answers yet? But the only way for me to get the answers is to actually build the thing.
Yeah, but I mean, I guess it's just the same thing, right? Somebody else can build the thing and work with you on making sure that you together as a team you're building the right thing. But yeah, so for me that was the first bucket. Is kind of, I think often when we are not clear on the idea, we tend to get attached more on the details because we're worried that the idea is not going to go the way we intuitively think in our head, even though it's not clear, right? And then the second is simply a trust problem, right? I think it's like, can you trust people that you hire and that you work with to make the right decision, right? And one of my boss back in the days told me, always hire people smarter than you so that you don't have to do their jobs.
Yes. I think that has been also sort of AWS motto, to always hire people who are better than already people who are in the company. Yeah, raise the bar, exactly. And I completely agree with that. And when I look back, the easiest part to delegate have been things I myself have never been good at. So UI development, for example, I know how to do high level stuff, but I've never become an expert in React or something. And when I had a senior in my team, it was easy for me to say, yeah, make the decisions. I trust you. You know better than me. But in the things that I have, tried myself, I have been, I think, over controlling, and I'm sorry to all of my teammates. Because
I think it's a normal thing. I've been very controlling on the thing that I feel most comfortable with, and I think it's because
so the solution is to know less.
No, I think it's trusting other people can also help you. Like I always have this mental model, like when I coach the engineers, like I always explain that, like how you build a snowman, right? Like I always explain this as you're building an idea, right? Your idea is the body of the snowman, right? You first you start to roll the big body of the snowman, but you need the head, you need the branches, the carrots, and all that make the idea better, right? Like you might have the central 80% of the body done by yourself, come from you, but all these additions are what make the snowman a snowman, right? Without all that, you just have a body, a ball, and then it doesn't get you anywhere. So I like to think of our ideas like that, like the central body of a snowman, and then everybody else in the company, in your team, are adding to it, and the only thing you can do is enabling that. It give permission for others to actually make your idea better.
Yeah, well, I'll learn one day.
I'm sure you.
We talked about this work as imagined and work as done, and let's assume we accept that this gap exists, and the gap is where the learning is. Can you give some practical tips of what does it mean for an organization to learn from the gap? Because it sounds good, but what does it mean for like an average Tuesday morning, not as a philosophy?
Yeah, so are you asking like how an organization can learn about the gap?
Yeah.
Is that?
Yes, because we say you can write better documentation, you can have a stricter process, you can have more controls, but how do you not get into compliance theater? How do you actually learn from it?
Yeah, so first an incident is absolutely a kind of a mirror of that gap, right? Because it happened, and then So if you study that incident, if you really spend time, you will learn about the done, right? But if you think a little bit upstream, if you want to kind of in the day-to-day of an of a system without thinking about incident, right, which is like the truth happening to you. Chaos engineering, load tests, game days are kind of three really good practices to understand some of the gaps, right? So chaos engineering, it will give you a very good understanding of what you think, how you think your system is gonna degrade, for example, or fail. So you inject a failure in the system, and then you make an hypothesis. You explain beforehand how you think your system is gonna behave, right? And then you actually go inject the fault, and then you can see in real what has happened. Now you study the observability, and the impact of the experiment. There you have two versions of to compare to, like your mental model pre-experiment and then the post-experiment, right? And then often that will be a structural gap that will be focused on degradation and failure mode, right? So that's a very technical gap. Load testing gives you another angle on the gap, more focus on is your system scaling as you imagine, right? So you inject load, or before injecting load, you kind of have your load test model, and you try to anticipate what will happen, like what will be the load characteristic of your system, what you expect that to happen. You inject the load test, and then you see the result. And that gives you a very good idea of where your mental model about how your system will scale. And especially what you want, especially for load test, is like you're interested in what's called the cliff, like the moment where the system just completely collapse, right? Because it will happen. Any system has a maximum that it can you can handle, right, in terms of load, and then it will collapse. And you want to have a very good understanding of that collapse. Is it at 120% of your scaling model or load model? Is it at 80%? Does it actually break much earlier than you anticipate? That's a structural gap as well that through load testing you can understand. Game day is a gap more about human coordination. So say you for example simulate the disaster recovery scenario, right? And you don't prepare the team, you just tell them, hey, there's the whole region is down, let's implement the DR, right? And then you see what happened. Is the team able to coordinate? Like, do they know what to do? Do they know how to, which service to fail over? Do they communicate well between each other? Do they know how to come back? All this kind of is human coordination, right? When you did the exercise, you hope the team was going to do well, right? And then in reality, they do a lot different, right? Or one of the best game day I always do at the beginning of my engagement is remove the team lead or like the hero from the team, like that, and then you see what happened. Like that's a structural gap between the imagining world and the done, right? A different version of it. So these are kind of practice-wise. And then you have operational readiness reviews, which is also a structural gap between how they think the system is going to be operated in production and how actually it is operated, like, and that. So this is kind of on the day-to-day where the system is, right? Like, yeah, in kind of what's the gap? Is that what you were asking?
Yeah, chaos engineering, load testing, game days, those are the tools, let's say, an organization can use to bridge the gap. And I
practice.
think
I call them practices. I would prefer to call them practices, yeah.
And I think one important event is also the incident itself. When you say somebody wakes up at 3 a.m., in a way, this person has to be this hero that fixes the thing no matter what, no matter if they followed the script or not. And in my experience, the next day is very important, or the day after that, where this person themselves can say which of the things they followed, which of the things didn't work for them, and the team can optimize the process using this person's first-hand experience.
Correct.
If you agree with that.
You've always had that experience that you try to, in an incident, you try to follow the wrong book, and you notice at step 2 it's already wrong. So then you use your intuition or kind of what you've learned from another team, and you go and fix it. Then the next day is exactly that. You don't really care about, in that, going back to root cause, you don't really care really about what the problem was. Is like, what you want to understand is, okay, what was different that the run book was not, that you had to skip the run book, or that you had to do, like, what were the context, what were the environment like, and then try to capture that so that you actually have more information about the real version of your system. But it's not intuitive for people to do that. They just want to go and
get over it. So we sort of identified that the gap has always been there. What I think, and we touched a bit on the vibe coding, but I think we can generally say that AI has widened that gap, because if previously we had that gap between departments, or between different roles of people inside the team, I feel we now also have that gap between the person who is implementing and the AI that's actually writing the code. A lot more and more people using AI for coding itself. Maybe one question is, do you see that yourself? Is the situation, let's say, with AI now also in place? And the second, when you say that the CTO starts vibe coding, I think it also, that plus the whole gazillion of articles about how you can build something in 5 minutes, that creates this narrative in people that, well, now engineering is easy. Why does it take a sprint or 2 to do things? And maybe an advice to people who are actually building things, how to explain that it's not easy, how to push back in a way that doesn't get them into trouble, but also explains that it's still hard.
Yeah, it's a good question. So I think the biggest problem with AI is that it hides the gap, right? Because now all of a sudden you are asking AI to make decisions and to create stuff, and then it will do all that things for you. The day after, or after the incident, you can't recall the mental model of the AI, what it did and why it did this. With human, you could trace back, what was the thinking behind, to some extent, right? So you had kind of a trace of the mental model of the person doing that. So the gap was visible when you look, so to speak, right? Now it's not, and then the problem is like, even if AI is really good, and AI is very good at producing code, right? Like it writes better code than me, and that's why, and I'm using it, right? And no problem by that. And if it's 99% of the time right, the problem is the 1%, right? And then at 3 a.m., your director is not going to blame AI for something that breaks. He's going to blame a human and tell the human to go and fix the problem. Because if AI cannot fix the problem, it will always fall back to a human at the end of the day, right? So if your AI had code 99% of the system, and at 3 a.m. you're thrown under the bus to go and fix something that's never been written by you, well, you're going to have to spend quite a bit of time to acquire the the knowledge to debug, to trace a problem, identify it, and then potentially fix it, right? So I think that's the risk, right? It's not that it's not good. It's more that when it's breaking, what happens to human, right? So that's why I think I'm a bit worried, and because it's so tempting to deploy stuff that you wrote with AI or that AI wrote, and then it works most of the time, yeah? And then so kind of it gives you a signal that yeah, it's good, yeah, like. But then the 1% of the moment where emergence or different component are gonna interact the way AI didn't plan for, then as a human to go and debug.
Yeah, I notice it a lot myself. I have always been proud of how fast I can answer questions about the system, exactly because of the problem with delegation and doing everything myself. And now that I'm more and more delegating maybe the development itself to AI, I do feel that I'm not as fast. Most of the time the answer is, yeah, give me a couple of minutes. I'll chat with my AI and then I can answer the question, which is peinlich, as they say in German, because you are supposed to know how your system works on different layers. And that is a bottleneck from one side. You're again limited by the amount of things you can keep in your head and reason about. On the other hand, as a lot of people are saying now, that's the load-bearing wall because it keeps the system working.
Yeah. I don't have all the answers on that. I think it's also related to a little bit to what you said. Like we want to keep, like to play the devil advocate, right? Like we want to stay in control. Maybe also that's part of the feeling uncomfortable when you don't know the answer of why something went wrong. But what really worries me is it's not understanding what is written. It's like when something goes wrong, it will go to a human, right? And at that moment, under pressure, you will be asked to sort a system that you have no idea how it was built, and that worries me. I don't know how we're gonna solve that, or maybe because I think it's a human problem. It's like humans are gonna be blamed, and they are today, and they will in the future, regardless of whether you have AI agent helping you. Something is gonna give up, something is gonna break, and it's not new, right? Liz and Brainbridge talked about the irony of automation in 1983, and she said that already back then it was for automation, but that the more automated, the more complex the automation, the more skillful you have to have engineers to fix the automation when it breaks, right? AI is next level, right? So yeah, it's 40 years old theory.
Which also brings me to the thought that we probably all noticed that AI is performing better at the hands of more experienced people. And what do juniors do? Like, what do people who are just starting into the IT world, how can they... what's the advice to them? Do they force themselves not to use AI, or because I bet it's difficult for them that from one side people tell them you need to learn fundamentals. On the other hand, there are all these tools which are also taking time to learn how to use. You don't just write a prompt and that's it. You also need to somehow find your way of working with all the AI tools also. Do you have an advice for people who are just starting?
Yeah, it's a good question. Again, the cynical part of me feels like it's like a old man me talking about the good old days, and I would say like younger engineers, they'll figure things out. They'll find a
They
way.
don't need
They'll
our
find a way.
advice.
Yeah, you know what? Like they'll figure it out. I think there's so many unknown at the moment, right? They'll figure out the way to work with those technology way better than we, right? When you're AI native, they will probably develop mental models that are very different than us, and that's okay. Now the only thing I would say is maybe be careful of efficiency, right? Because efficiency drives speed, and like try not spend time at learning and all this kind of stuff. And I think that's probably can bite back. I think understanding how to debug a system without AI probably is going to be an important skill. Like, imagine you're at 3 a.m. and Claude is not available, and you cannot ask it what to do. Like, what are you gonna do, right? Are you gonna refeed the whole context of your application to another model? Like, probably it's not gonna happen. Like, all this kind of stuff is like, it's the same. Like, flying blind is not something new. Like when you don't have monitoring, when you don't have, or you don't have Slack, or you don't have Team, or that breaks during an outage, you're gonna have to find ways to go around it. And then I think if you completely rely on AI for everything, that becomes your single point of failure, and it's a big one in case of an outage, and you don't have AI to help you, or AI fails and doesn't give you the right answer and tells you, sorry, I don't know. Then what? Like, you tell your boss, I'm sorry, I don't know. We're gonna stay down. Claude doesn't know.
It actually, when I started working on the current startup, Ops Worker, the original intention was that a lot of development will use AI. There will be a lot of code coming into production, and you will have even more observability tools, more dashboards, so the load on SRE will grow. So why not also use AI to gather all that information, present to the person, and then help them deal with the complexity. But I'm very worried that people will use tools to delegate thinking as well. So just, it's all right, yeah, probably correct. Next. Is there a version of the tool where this can be prevented, or this is not even a function of a tool, but rather training people or asking them not to do this, not to delegate thinking?
I think there's a version of tools that, again, is related to efficiency, right? There's a version of tool that can push back and that can enforce learning mechanism, like struggle, where. And actually, I just published the Resilience Companion is really around that. Actually, open source today. It's kind of, it's a companion that I wrote that I built to kind of have a working demonstration of how AI can actually be helping you to learn. It's so easy to delegate everything to AI, but then you don't learn anything. And again, going back to when something is going to break, if you haven't learned anything, there's very little you're going to be useful for. So you want to keep learning, right? And so you need to use AI in a way that challenges you, that puts you in a mode of where you struggle a little bit, and then you have to go and find the answer by yourself, and then it in kind of helps you create mental models about the system, because you've you have to think about it. That's exactly how I built the AI companion, right? It's like it asks you what you think the system does, like, and more detail will push back on when you try to stay too low. Will and then will go and verify when you are really uncertain and kind of. And then that gives you a very good indication of where you need to spend time, because your mental model of how part of the system works and how it is coded is so different. And I think it is possible. Now, it's not going to be a standard in the industry, because no one wants to spend more time doing things. The industry capitalists loves efficiency. They want to go as fast as possible. And it's so tempting, right? It's so easy to offload cognitive struggle. And the brain loves that. The brain, if you can make things easier, it'll say, hell yeah, it's going to jump into the wagon. So you need people that are aware, that they need to struggle to learn.
Mm-hmm.
And then tell them why it's important. But I don't see that coming naturally. Like it's.
To be honest, I think it's the first year in the industry that I'm feeling old because every time I think I have delegated too much to AI and oh my God, I need to slow down and not delegate more. I'm reading an article or talking with a peer that says that I need to delegate even more because otherwise I'll, stay behind and not be able to do things and the world has gone ahead and I'm still here.
FOMO.
Yes, exactly. Permanent FOMO. I thought I was in FOMO and then after, 2021, 2022, all this started, it's like 10 times more the FOMO. And my question would be, does it even make sense to advise somebody to slow down, or as you said, it's not gonna happen? And how do companies that now have this pressure to you must bring AI to the organization, how do they do that in a way that doesn't bite them afterwards because it was too fast and into the unknown territory?
Yeah, so the crisis. The answer is crisis. Like they will be faced with a reality that they just don't understand what they have deployed in production. And at that moment, you don't have a choice. It's either you face reality and you look at what you've done and how your workflows have been, and if everything was over-delegated to AI, you can make two decisions, either to continue and keep getting into crisis situations, or you can slow down. And I already see customers slow down. Actually, many of my customers that engage with me, I've been in what I call undeclared crisis, is that they have similar incidents happening, and AI is exacerbating that, and they've come to the realization that they need to change and something needs to give, right? And often is spend time learning, and they are making those decisions. The thing is, it's learning through crisis, right? It's like it rarely comes without the crisis. So crisis is a very good incentive to go and change things because you are in that situation. So yeah, but that's not much difference than anything else we do in life. We often learn through failures or through crisis, right? Like touching the hot oven, right? Because that's how.
So you mean that they will adopt, let's say, AI so much that it will bring them to a new crisis and they will learn from it, or do you mean that they will need to learn already from the incident?
they'll not have a choice. The more they adopt AI, they will be in a crisis that they can't explain and they can't debug, they can't recover from. The outages, at some point, outages are going to be so long, much longer, because they can't understand the system. It was not written by them. It was delegated to AI. Thinking was delegated to AI. Documentation is completely outdated. So a human will have to go and understand at that moment, under pressure, at 3 a.m. in the morning. That will take some time.
I see.
Now already start to see this happening in few customers. It's like the incident happen, and then rather than, like you said, like when you write the code, you know intuitively from the error what has happened. Like you receive the alert and you're like, oh, damn it, I intuitively thought, you intuitively think about what might have gone wrong. So you start investigating there, right? That's called the intuition that is so important in incident response. If AI writes everything, you don't have intuition anymore. You receive an alert, and at that moment you're like, all right, let's build a mental model of how the system works. Let's dig into the code, try to understand what happened. Yeah, and it's going to take a lot longer, right? And your customers are going to scream at you, and they'll tolerate it a few times. And 3, 4th time, they're going to tell you, either you change or we change provider. And at that moment, you will have to make some choices. And the choices will be, all right, let's use AI, but let's figure out a way to actually spend time, understand what AI is writing, and or there's gonna be new disciplines about let's AI write, but do more of those chaos engineering, do more of those game day to actually understand, how your system is failing, and learn how to debug on a system you have never written, right? Now there's a lot of that already today. Like it's rare that you write everything in a system that you debug at 3 a.m. But you have intuition about what went wrong because you wrote part of the system. You kind of and maybe I think that is probably the only viable solution is do a lot more of chaos engineering, a lot more load tests and game days, so that you can learn from that gap, right? Because now that gap is even more present. So, but is that gonna happen? I don't know. Maybe there's a new discipline that's gonna show up about understand.
I'm sure there will be remixes of previous disciplines now adopted for AI. But it's interesting, coming back to the open source you mentioned that you published today, or if the tools themselves can help you build that intuition still, that would be interesting to extract the exactly enough amount of information to build this intuition for you without knowing every single detail. Alrighty, then if we try to let root cause it one last time and summarize what we talked about. We talked about the gap between the imagined and the done, and how AI widens it, how nobody wants to fall behind, how everybody is in a FOMO. And if you had to root cause or find the root causes of this problem, of this gap, and of why engineering organizations are losing their cognitive capacity. Is there something we missed? Do you want to add something? Or the answer is really, okay, go full speed and then learn from your mistakes.
I don't know if I would say learn full speed. I think I will actually point them to your Substack. I think the article that I read about how you wrote about how your journey to delegating to AI, right? And I think that was wonderful because you talked about emotionally also what you were giving up, and I think people need to read things like this. Like we need to stop telling only the stories that FOMO everybody, like the 10x that just go full speed, it works. I want to see, I want to see stuff in production that have been completely written by AI. I want to see a real enterprise system that has millions of customers managed and run by AI.
Mm-hmm.
Without problem, right? And then without having humans to delegate to at 3 a.m., then I'll be convinced. At the moment, I'm not. Like, it's easy to write on Substack, on LinkedIn, that you've written amazing tools with AI, and great. It's awesome, right? But product, putting that in production, operationally, production ready is completely another beast, right? It's the same if you you see this in often when you build a prototype yourself, right? The code works awesome, right? But now 1 million customers are going to start using that code. Completely different story.
Yeah, absolutely.
It's completely different because you need to start to think about everything around it: the monitoring, the deployment, the operating, the alarms, the on-call relation, the documentation, the onboard. The code is such a small part.
Yeah, of engineering, indeed. Yeah.
Of engineering. So maybe all these AI tools are gonna start tackling everything around, But as long as you only do the code and you tell me, now it's ready
That's
to
done.
go in production, I'm gonna say, okay, show me, because I don't yet believe. I spent a lot of time running system in production, and the code is the least difficult thing.
Yeah,
it's the
true.
least. So.
Yeah, I always think back of, I think this is Unix philosophy, make it work, make it nice, make it fast. So the make it work part is something AI can help you with a lot. Yeah, it works. But then making it right, meaning making it architecturally clean and so that it is expandable and maintainable and yada, 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 and observable.
Mm-hmm.
That part is still, it requires human involvement and not just one human involvement, but a team. And then making it fast, making all those game days and load testing and making sure it works smoothly for the amount of users you expect. That's something we still have to do.
And that your customer found useful, right? You can build as much code as you want with AI. If your product is not what the customers wanted, no amount of AI is going to help you. It's about you talking to your customer, and often customers express something that they want, but they want something slightly different. It's just that they didn't have the word to express what they wanted. So a lot of the work as a software organization is trying to understand what their customers want first, and then provide answers and then solely find which of the answer is better, and then then iterating on that, making compromise, because often you cannot serve everything. And then all that is human. It's a relationship with your customers. Is prompting your AI correctly. Your AI, can be very, very correct, but wrongly correct.
Yeah. Very confidently wrong.
Confidently correct. Much better way to say it.
Alrighty. Do you have any practical recommendations? I mean, you recommended my blog post. Thank you for that. Obviously,
Yes, it was great.
there's your book that people can read. Any other books or resources on generally how to maybe implement technologies within organization in the right way, how to be mindful of these gaps and resilience in general?
Yeah, I mean, the whole resilience engineering field is interesting, right? I think, but is very, you'll learn a lot. I think cognitive science is super important. I'm fascinated with psychology because I think it has also a lot of impact. So I think, I always, and I wouldn't recommend necessarily one book. I think it's go explore other disciplines, other industries, other sciences, because you find a lot of good in there, right? Especially around human behavior. I think it's so fascinating because it's at the center of everything we do, even though AI is going to be pushing, to write code fast. At the end, we're still in the business of human relations with our customers. No amount of AI is going to fix that. Actually, it can do it worse, right? I hear a lot of comments from customers that cannot have a human contact when there's an outage. It's a Google form or it's a AI chat, and it frustrates them insanely when there's a problem, right? So humans are gonna have to find their place as well there. So I would say, yeah, like all that stuff from. I would say the Bible is like go see How Complex Systems Fail from Richard Cook is probably like amazing stuff. John Molspo wrote a lot of cool stuff around incident response. All Nagel is about safety 1, safety 2, all this kind of stuff. So like I think a bit of all that, and yeah, being curious about other areas. I think it's a good thing.
Cool. Yeah, thanks for that. And I have this thing, which is also a problematic thing for building podcast episodes, because now I have to produce them strictly in the order I create them. This is where every guest leaves a question for the next guest. And the previous guest, Mark Bevin, he left a question, which is, I think, should be difficult for you because you share a lot already of what you're learning. But maybe you can answer, is there something you have learned this week that you haven't shared yet? Something that would be interesting.
Yeah, I mean, I'm still scared a lot. Like I open sourced the companion today, and it's very scary, like to expose yourself. And it was written with code, so kind of all my other repos have been written entirely by me without AI, and now I'm kind of jumping into open sourcing something that I worked on with Claude. I have to say that it took me quite some time to feel comfortable with that. So I would say I learned that I'm still scared about.
Yeah. Even after 20 something years in IT, you can still be scared of posting something online.
Yeah, and it's tough because you expose yourself to the world, and being in a podcast, sharing ideas, writing a book, it's scary. I mean, kudos for you, right? You're starting your own podcast, and that's something as well that is.
I'm horribly scared as well. One of the things is that the more you are able to do analysis of any question, and I wrote about this as well lately, that you are able to see both the positive and the negative sides, and I can critique myself endlessly. So whenever you put something out there, you sort of cutting that critique out, and you're leaving this positive thinking of, okay, my opinion matters, my open source matters, my product matters. And we are subconsciously, I think, afraid of all the critique that can come, which we already know, because there's no perfect system.
So why did you do it then?
That's a good question to me. I think, and I mentioned it last time with Mark, that as you said, there must be content out there which is not 10x improvement in 4 days, and here you go, do this and that. And I was not seeing that content, and I thought, as usual, as I think any person who writes book, they say, well, I searched for this and that, I didn't find it, so I wrote it. This is one reason. And another reason is to maybe selfishly also to get better at expressing myself, to get better at asking questions and answering questions in a way that people understand, so that I can bring out more awesome ideas and people understand that.
On your first point, I think this is why I like your post. It was just so different than the rest. It was honest. It was, you could see that. It was brilliant. Like, because, you shared emotion, your struggles, and that works, right? So, and it spoke to me to some extent, because I think you wrote about the delegation and kind of slowly giving away at each steps of the way, and I haven't managed to go all the way yet. Like the last steps of your on your post with OpenClaw, and then doing the thing there. I'm old school. I still run locally. I'm very controlled and human in the loop, and so it's and it's interesting because it made me think about that. Is like, if I do not evolve following like the same way as you've gone all the way, I got worried. Am I going to not be relevant in a few years? You think there was a moment, reflection that I had?
I hope not. I don't think so. I think the industry is gonna hit the wall and realize you can't keep delegating more and more of the thinking, and people who have built something themselves will always still stay relevant because of how fast how much intuition they have. Even if it's not a system that you have built, you have seen 10 other systems similar to that system, so you do have the intuition. So I'm hoping not.
Yeah, I think maybe the relevance is more like, I'm not understanding anymore the development workflows. They are, like, it's multiple agent, like the whole mental model of the relation of the human with the act of shipping product. I think that's what your post made me question, that my relevance into understanding my relationship with building product, and if I was going to be able to advise my customer in 5 years if I don't adopt that, because the problems are going to be different, and if I'm not there, right, because younger engineers are going to go there, they're already there, they're already further, like it's natural for them, and I'm not I've resisted to some extent. I've and then so that's what I meant. Is like, am I going to be able to understand that?
Only time will tell. And I also read the joke that we are the generation that didn't want to accept cookies, but we accept giving code and ideas to AI. So that's kind of contradictory. Yeah, we don't know. I don't think anybody knows if tomorrow everybody will say that this was all a mistake, or if it will continue and we will build more and more agentic systems, supporting agentic systems, fixing other agentic systems, etc., etc. I'm excited to see.
Extremely tiring as well, because it's like a completely new space, and it's exhausting.
Finally, we thought we understand everything. We are in our 30s and 40s, and we can just 46. enjoy the
biggest
years.
revolution in software happened at 46, when I thought after 25 years. I think actually I've never thought about it like this, but I think you have it so right. I think that's why it's exhausting. It's like, finally I thought that I had it right, but boom, like in a couple of months I have to relearn.
Yeah, keeps us on our toes.
You have identified the problem. Thank you.
The root cause.
That's it. That's the root cause.
Do you have a question to our next guest?
Yeah, I would guess the what surprised you the most in the discipline you were the most comfortable with?
Okay, good. That's, I think, generic enough for any person who is good at something to answer what surprised them in that thing that they are good at. Okay, thanks. Thanks for that. So that was Adrian Hornsby, founder of Resilium Labs, former AWS Principal Engineer, and author of Why We Still Suck at Resilience. And one of the few people in the field who can say something uncomfortable without making you feel bad about it. If you want to go deeper, his book is available on LearnPub, and I'll link it to the description. And it's not a checklist, it's not a framework with a 5-step plan. It's a careful look at why the things your organization is already doing aren't building the capability you thought they were. That's a rare kind of book, and it's worthy your time. Find Adrian at Resilium Labs and on LinkedIn and on Substack. And if this conversation made you think, share it with someone on your team who needs to hear it. I'm Nune, and let's keep root causing it.